I would like to introduce the idea of entanglement. Entanglement is the most important form of the so-called quantum correlations. So, in order to understand entanglement, you need to understand quantum and you need to understand correlation. Let me start from correlation. Suppose you have a system made at least of two parts and you perform measurement on both parts. And then you look at the data and you see that they are not distributed randomly. Suppose you see one for whatever quantity you are measuring on one side, and then on the other side, when you see one here, you see two or sometimes three, but never four. So at this side, the numbers are not random, and they are influenced in some sense by the result of the other experimenter. So when you see this behavior, you see that the data are correlated. One very simple example: if you are in a car and then you measure the position of the front of your car and on the back, the rear of your car, you will see that the position of the front of the car is always a couple of meters larger than the position of the back of your car. This is trivial, of course, because this is a rigid body. But just to understand that looking at correlations, sometimes you may extract information of the nature of your object. Now, quantum. Quantum is the extension of the Newton physics, which is valid when your particle is becoming very small, with low energy, and in general, when is microscopic or nanoscopic. It is not falsifying Newton, is just extending the realm of application of Newton's law to objects we cannot see. And now, quantum and correlations. And some correlations may be obtained by making action in a point and in another point, and then making the two parts of the measurement to communicate. You can perform this kind of experiment as following. You look at your watch, and then you phone to your brother and say, "Oh, look at your watch, brother." And your brother is saying, "Well, this is 10:32," and you check that it's 10:32 also your watch. So they are correlated, but of course, the origin of this correlation is that both of you are checking your watch against some common watch, like a website of the National Meteorological Institute. So the result of your measurement are correlated, but the origin of this correlation may be traced back to some action you perform locally and then communicate between the two. And here the communication means is, of course, internet. But physicists realized that there are experiments where there are correlations that are observed in experiment, they cannot be explained. There is no way to explain the result of the measurement by tracing back to some common source and communication. In this case, the two parts of the system should have been interacted at some point and then left free to evolve. In this case, when you cannot speak of a common origin and communication-based correlation, you say that the correlation are of quantum origin. And one of the most important forms that may be exploited for some task is entanglement. Then I'm done. Very easy, even if you are a monkey.